Welcome to this comprehensive exploration of one of the fundamental pillars of probability theory, the addition rule. Whether you are a data scientist, a student, or simply curious about how the world works, understanding how to combine the probabilities of different events is crucial. Probability isn't just about gambling. It's the mathematical language of uncertainty that governs everything from weather forecasts to financial markets. Before we dive into the rules, let's establish the foundation. In probability, we deal with a sample space, denoted by S, which represents all possible outcomes. An event is a subset of that space. For instance, if we roll a six-sided die, the sample space is the set of numbers 1 through 6. The probability of any event A, denoted as P of A, is a value between 0 and 1, representing the likelihood of that outcome. Understanding this sets the stage for the addition rule, which helps us calculate the probability of event A or event B occurring. Section 1. Mutually exclusive events. This is the simplest form of the addition rule. Two events are mutually exclusive or disjoint if they cannot happen at the same time. Think of a coin flip. It can be heads or tails, but never both simultaneously. In sports, a team can win, lose, or draw a single match. Mathematically, if A and B are mutually exclusive, the probability of A or B happening is simply the sum of their individual probabilities. P of A union B equals P of A plus P of B. Let's look at a practical example. Imagine a large warehouse where 30% of the robots are manufactured by company X, 20% by company Y, and 50% by company Z. If we pick one robot at random, what is the probability it was made by company X or company Y? Since a robot cannot be made by two different companies at once, these are mutually exclusive. We simply add 0.30 and 0.20 to get 0.50 or a 50% chance. This principle is the bedrock of categorical data analysis. Section 2. The general addition rule. Life is often more complex. What happens if events can overlap? These are non-mutually exclusive events. For instance, if you are selecting a card from a standard deck, the event picking a heart and picking a king are not mutually exclusive because the king of hearts exists. If we simply added the probabilities, we would be double counting that king. This leads us to the general addition rule. P of A union B equals P of A plus P of B minus P of A intersect B. We subtract the intersection to ensure every outcome is counted exactly once. Section 3. Visualizing the overlap with Venn diagrams. To truly grasp the general rule, we use Venn diagrams. Imagine two overlapping circles. Circle A represents all outcomes for event A, and circle B for event B. The overlapping area in the middle is A intersect B, A and B. When we calculate the total area covered by both circles, we add the full area of A and the full area of B, but notice how the middle part gets covered twice. By subtracting one instance of that intersection, we get the correct total probability. This inclusion-exclusion principle is vital in set theory and advanced statistics. Section 4. Real-world application in data science. Consider a marketing study of 1,000 customers. Statistics show that 60% of customers bought shoes, event A, 40% bought shirts, event B, and 15% bought both. If we want to find the probability that a customer bought a shoe or a shirt, we apply our rule. 0.60 plus 0.40 minus 0.150 equals 0.850. This 85% tells the marketing team the reach of their product line. Without subtracting the overlap, we would get 100%, which is a statistically significant error that could lead to poor business decisions. Section 5. Nuances and common pitfalls. A common mistake is confusing mutually exclusive with independent events. Independence means the occurrence of one doesn't affect the other, like two separate coin tosses. Mutually exclusive means they cannot happen together. Also, as the number of events increases, the formula expands. For 3 events, A, B, and C, the formula becomes more complex, requiring us to add individual probabilities, subtract double intersections, and add back the triple intersection. This complexity is why automated statistical models are so valuable in modern research. In summary, the addition rule is the tool that allows us to navigate the logic of OR. It reminds us to always look for the overlap. From the early works of Blaise Pascal and Pierre de Fermat to modern econometrics, these rules have allowed us to quantify the unknown. As you move forward, always ask yourself, can these two things happen at the same time? That answer will dictate your path through the fascinating world of probability. References: Gujarati, D9, 2022, Basic Econometrics. John E. Friends, Mathematical Statistics with Applications. Montgomery, D.C., and Runger, G.C., 2018, applied statistics and probability for engineers.